Hello all. This is John Noguera. I am the Chief Technology Officer and co-founder at SigmaXL. Today's webinar, we are introducing the new features in SigmaXL version 7. The first area is in the automatic assumptions testing for t-tests and ANOVA. So we have red light, yellow light, green light, or red highlight, yellow highlight, green highlight, for the various aspects on the assumptions of a t-test and an analysis of variance. Green means everything's okay. Yellow is a warning, just something to look at. And red means it's a serious violation and you really need to take action. We consider normality, robustness to normality based on sample size, outliers, randomness, and equal variance. Normality. What we do there is very simple. If the Anderson-Darling p-value is less than 0.05, then you're rejecting the null hypothesis of normality, and we highlight that as yellow. The reason I do that is because you can still be robust to non-normality, but we want you to be aware that you have some non-normal data. So automatically, if you see yellow in the normality report, that's an indication of non-normal data. And we also then report the skewness and the kurtosis. If the p-value is greater than 0.05, greater than or equal to 0.05, then the cell is highlighted as green. So green is good. All right, so in version 6.2, we added some templates to test for robustness. And what we did was we did extensive Monte Carlo simulations with varying degrees of skewness and kurtosis and a range of sample sizes from 2 to 2,000. Each t-test or each ANOVA had 100,000 replications, and we incremented the sample size to the point where the alpha, the observed alpha, was within 20% of the target alpha. So if, for example, a false alarm rate of 5%, we said that if alpha was between 4 and 6%, we would consider that robust. So that's how we define robustness. So all that work that was in the templates, robust, t-test, and ANOVA, minimum sample size, we built that in, so now it's done automatically. And you get the report if sample size requirement, if the sample is greater than the minimum, it's green. If it is less than the minimum, then it's red. So saying, look, you have non-normal data, and you do not meet the minimum sample size for robustness. So that's given to you as a warning. And then also we recommend the appropriate non-parametric test. So in the one sample case, it'll either be Wilcoxon or the sign test, and that depends on other things like symmetry. And then in the two sample case, we'll recommend the Mann-Whitney, and in the multiple sample, we'll recommend either the Kruskal-Wallis or the Moods median, depending on whether there are outliers. And that's all done automatically. So on the outliers, we use the box plot rules. If there are no box plot outliers, then it's green. One potential outlier is 1.5 times the interquartile range. And then a likely outlier is 2 times the interquartile range. That one is not seen on the box plot. However, we do report it as a likely outlier. And then we have the 3 IQR, and we call that an extreme outlier. Okay, so you have potential, likely, and extreme. And if it is potential or likely, it's highlighted in yellow. If it's extreme, it's highlighted in red. Another little thing that we do that's kind of nice is we then remove the outliers automatically and retest for normality. And if the data are normal minus the outliers, we tell you that. Now, we still highlight it in red or yellow, but point out that your data actually are inherently normal if the outliers are excluded. Now, I'm not saying that you can just remove the outliers, but it's good to know that your non-normality may be due to outliers. So that's something that is given in the report. Another test that is included is test for randomness, serial independence, and that's the non-parametric runs test. So if the p-value is greater than 0.05, we're good. We conclude that the data are random. If the p-value is less than 0.05, we highlight that in yellow. If the non-parametric runs test p-value is less than 0.01, we highlight that in red. So we're saying that the 95% confidence, we're calling that yellow, and at the 99% confidence, we're calling that red. There you would look for a trend. You would look for something that obviously you'd want to look at your data with run charts, with other graphical tools. This is all a text report, and the point is that we're not trying to replace the graphical analysis, but give you a nice highlight summary of the status of your of the assumptions of your t-test and your ANOVA. Finally, in the two-sample or multiple sample case, we do a test for equal variance, and if you're running an equal variance test and the data do not have equal variances, then a warning is given. If you have unequal variance in the data and you're not using the right test, then we'll give you the appropriate warning for that. All right, so let's look at an example now. I'm going to go in and run the customer data is what we have in our workbook, and I'm going to do an analysis of variance of overall satisfaction by customer type. SigmaXL, statistical tools. So the menus for these particular items have not changed. There's no difference here. The difference is in the dialog where you have a display test assumptions report. Overall satisfaction by customer type, and then I check test assumptions report. And this is my report. Everything is the same now. We just have this new text report. And most of it's green, so that's good. We just have a couple of cautions here. For example, for customer type 2, that you have some non-normal data and there's a potential outlier. So it is robust. There's a potential outlier. And this is the sort of thing that you would then go back and you would do your standard graphical analysis. So I could do, for example, a box plot and overall SAT by customer type. Oh, and there's my potential outlier. Please note, as I mentioned, we, in addition to identifying potential outliers in the report, will also give you what we call likely outliers. But the box plot only separates the 1.5 IQR and the 3 IQR. So the potential and the likely will both show up as the light circle, and the extreme will show up as the solid circle, or the solid dot. So that's test assumptions for one-way ANOVA. Let me pull up a one-sample test with some non-normal data. So I have small sample non-normal data. So this is a task time, and it's a difference in task time before training versus after training. So we're going to do just a one-sample t-test on this difference in task time. So you could have done a paired t-test if you had the before and the after data. So this is the difference data. So again, I'll just go to statistical tools, one-sample t-test. And in this case, I'm going to do the difference. I'm going in with a specified null hypothesis of 0. I'm going to change this to, the alternative is to less than, because it's a one-sided test. And I will again display the test assumptions report. So this is the one-sample t. So again, we have all our regular statistics. Now in this case, we have non-normal data, and it fails the robustness test. So what's happening here is actually, it's not a skewness problem, it's a kurtosis problem. It's failing the robustness test. It would have needed a larger sample size, 16 versus the 15 in the actual data. There are no outliers, and the randomness test is okay. So what's being recommended is the one-sample Wilcoxon. And in a little bit, we'll run that one-sample Wilcoxon test. So because of the fact that you have non-normality and it's not robust, the Wilcoxon test is being recommended. So just a quick one, if I do a histogram of this, you'll see what's happening with this particular data. As you can see, it's kind of a uniform distribution or possibly bimodal. It's a small sample size, so you wouldn't want to call it necessarily bimodal, but it's looking more like a uniform distribution rather than a normal distribution. And that's why it was triggering as not normal because of the kurtosis rather than your more typical skewness problem. And because of the fact that it's symmetrical, the Wilcoxon is being recommended rather than the sign test. The non-parametric Wilcoxon is being recommended. If it was a skewed distribution, we would have recommended the one sample sign test in the report. So those are the red, yellow, green for the t-test and the ANOVA. So then we'll call the webinar, we'll call it a wrap, and I thank you all very much for your attention and for your attendance. The PowerPoint is available immediately, and the data sets, the examples that I've used are all in the workbook, and the data sets are available with the installation of version 7. So with that, again, thank you all very much for your participation.